All right, so let's get started. Today, you will hear from Yair Weinberger, our co-founder and CTO. He's been with Alooma from the start for the last 3 years and has been involved with data pipelines for the last 15. So today, Yair will discuss the history of data integration and what has changed to call for a more modern data pipeline and what this means for us. He will also share some interesting stories of how Alooma has helped some of our customers' businesses. He's also going to run through a live demo to show you how Alooma works under the hood. He'll be using an example of migrating Oracle data to Amazon Redshift. So let's go ahead. I'll hand it over to Yair. Yair?
Thank you, Jason. Welcome everyone. And as Jason mentioned, my goal is to describe the modern data pipeline and what have changed in data integration in the past few years and how businesses are today utilizing their data. And I want to start with saying, and I don't think this actually needs any proof anymore, that data is transforming every business. And what we see is we see that more and more companies are getting their competitive advantage from being able to utilize their data. And this is even not very new. This trend have been going on in the past few decades, but even today, if you look at the top companies in terms of market cap, they all view data as their core asset. For example, and Google is probably the best example for it. So data is the core asset of every business. However, data is broken and siloed across the organization. And when we look at especially at the older organizations that exist already for a few years or maybe even a few decades, the data is spread across many different systems. And it could be data that's coming in from endpoints, it could be data in ERP and CRM systems, could be data in RDBMS databases or log files. So to start with, it is very difficult to access the data across the organization. Now, if you look at data integration, and this is not a new problem, this problem of how to access data and how to deal with data that is broken and is siloed, it's a very old problem. And if you look at how the market has handled that problem, we've seen two different product categories. One category is what we call batch ETL, or extract, transform, and load. And in this category, products like Informatica or Dell Boomi, Oracle Data Integration, etc. And the point was, okay, let's create some batch jobs, and those jobs will schedule some kind of data collection, and we'll push it upstream. And this approach has been very successful over the years. And on the other hand, there was the application-to-application use cases, or what the product lines that are called enterprise service bus. So how to connect with, let's say the organization has many different applications, how to connect those applications to one another. And TIBCO is probably the most notable product in that category. MuleSoft as well, if we look at some of the newer solutions. And the service bus was focused mostly around real-time and API connectivity, so connecting different applications to one another, and a lot of, let's say, SOA, or service-oriented architecture was built around those service buses. So what have happened? What have changed? Or why do we need even a modern data pipeline? So one thing that changed is the cloud. And everyone today is moving to the cloud. And moving to the cloud actually consists of two different things. One is that the data itself for the organization is no longer on-prem, it is moving to the cloud. Because it's cheaper, because there are a lot of advantages of moving off of a data center on-premise to the cloud. But also, a very big shift is happening towards using SaaS services. So instead of having the CRM and ERP systems on-premise, now we are using all kinds of SaaS providers, and the data already exists in the cloud. So for example, we use Salesforce and Marketo and Zuora and Zendesk and many different SaaS vendors. And what that means for the ESB, for the service bus, is that the applications can no longer speak to the, those SaaS applications no longer speak the language of our service bus. I mean, it's now they have their own APIs and their own ways to communicate with them. And of course, they're not going to adapt to our applications. On the other hand, we have real time. So real time data is becoming more and more important. And if 5 or 10 years ago, when I did a credit card purchase and I would see it on my statement after at the end of the month that I would get it mailed to my home, today I can see it on my phone probably like 10 or 30 seconds after the purchase was made. So really, real-time data is becoming more and more important and is powering more and more business use cases. Now, if we take those two trends, real-time data and cloud, basically the distinction, the very clear distinction that we had between the service bus and the ETL is becoming very vague. Because on one hand, we still need all of our applications to talk with those SaaS applications as well, and be able to connect to their APIs, etc. On the other hand, our ETL, our batch ETL, no longer fits the bill because we need the data available in real time, or at least near real time. Probably it's not milliseconds, but seconds to minutes. So what happens is that we start creating all kinds of ad hoc solutions. Some of them are based on open source tools. Some of them are just some scripts that we write, and they basically create that mess of trying to connect together our traditional, let's say, data warehouses, data structures, data silos with those new age cloud and real-time data, and it's becoming a mess. And what we see is that a lot of the time, for many companies and organizations that we've been speaking to, they spend a lot of their time in trying to adapt their ETL to that new age, to all of those applications that they want to do. So let's take a step back now and ask ourselves, okay, what do we want to do with data? And usually the first thing that we want to do, and again, when cloud migration is a very big topic, and my goal today is to speak about the first step. And the first step that people take is usually migrating the analytics to the cloud, analytics and deriving insight from the data. The reason that's usually the first step is that applications, let's say the organization has 1,000 applications, and all of those applications are using existing databases on-premise, and they can use maybe Oracle or even IBM DB2 for the older ones. And migrating those applications or doing a full migration is usually a very long process, maybe it takes years. However, analytics is usually something that's easy to start with. Today, there are very cheap cloud data warehouses. So Amazon Redshift and Snowflake and Google BigQuery, all of those are, let's say, 10x cheaper if we compare them to Vertica or IBM Netezza that we used to have on-prem. So there is a very strong incentive to start migrating analytics to the cloud. It would be much cheaper. And then it's relatively easy. I mean, all you need to do is to make sure that you can maintain consistency between the data that's on-premise and the data that's in the cloud data warehouse. And once you've done that, you can basically start running your analytics against the cloud. And when I say we take a step back, I want to ask, okay, what do we really want to achieve? And as there is today a lot of buzz around machine learning and AI, etc. But I would say there is an underlying requirement, and to start with, to start enabling our entire organization to use the data and to utilize it, we need to take care of some very basic needs. And so we need clean data, meaning we know exactly where everything is, and it's not and it's being already processed in the pipeline. We want to have very low latency. We want very easy SQL access to the data. And this is the canonical analytics query. So analytics is actually, it's a very simple problem. All we want to do is we want to select some dimension, select some metrics from some fact table, and group by, usually within a date range. That's the that's the canonical analytics query. And the way what's actually said, a little bit said about it, is the way we put the data in, we actually determine how we are going to access the data. So for example, If we look at the old on-premise data warehouses, we used to have indexes in Oracle, or in Vertica we used to have projections, and all of those basically determine data access. So we would usually set up our database based on the query pattern that we are going to do. With the cloud data warehouses, this is shifting. Nowadays, the new ones don't really care how we store the data. So Amazon Redshift still have sort keys, but if we look at Snowflake, for example, or Google BigQuery, there is no concept of indices or sort keys. Basically, we just need to make sure that the data is in there, and then we can run those analytics queries with very high efficiency. So if we try and give let's say, the hierarchy of needs for data, and I'm going to focus today on the lower level of that pyramid, because of course, machine learning is nice and important, but in order to be able to actually do that, our first mission is to provide the infrastructure and to provide easy SQL access to make sure that we know where each piece of data lies, and that's what I want to focus on in this presentation. So we have a very clear mission in front of us. We want to take whatever we have on premise in any way that it exists, and we want to be able to replicate it to a cloud data warehouse for analytics, while maintaining easy SQL access and knowing where everything is, or data governance. So I do want to mention like the data lakes and the Hadoops of the world, because this is something that was very popular in the last, let's say, maybe 8 years ago to 3 years ago. And the concept was, okay, we want that, what I have currently on the slide. So let's push everything into a data lake without caring about formatting, without caring about schema, and take care of everything we need when we read the data. So when the data is being read, we'll see how we want to read it, and basically it's called also schema on read. In my opinion, this concept have failed, and the reason is that, and again, there are a lot of use cases where Hadoop makes sense, but if we want to use it for analytics and we want to enable access to our entire organization to the data, I believe that we have to maintain the schema on write, and we have to maintain where each piece of data moves into over time. So instead of pushing everything into a data lake, what we are trying to do is to push it into a data warehouse, a cloud data warehouse, and detect the schema changes as they happen and maintain the schema consistency. So Alooma is a data pipeline as a service company. And our goal is to make the modern data pipeline very simple, or to make that transition of moving analytics into the cloud very simple. And we have some very basic principles. The first one is to try to move everything from batch to stream. So try, at least attempt to treat everything as a stream of data. And some things are naturally streams, like clickstream events on a website. Some things are not naturally streamed. So let's say if we're looking at an RDBMS database, naturally it has tables, and the old traditional way to do it was to dump those tables and then load them. However, if you do look at a database from a fundamental perspective, it is actually a stream. Because if you look at the change log, so in the example that I'm going to show very quickly, it's the Oracle redo log. So everything that happens on a database is basically written to the transaction log. So you can look at a database representation as a transaction log of all of the actions that happen on the database. So we are trying, again, in order to achieve as real-time data as possible, Alooma is trying to treat everything as streams. The next thing over is to detect the schema and then track the changes in the schema over time. And then if the source has schema in it, then of course it is very simple. Let's just read the schema from the source and replicate it. If the data does not have schema, the schema will be inferred from the data itself. And then, well, I'm not going to read through each and every one of those bullets, but basically, as I mentioned before, having a stable infrastructure, so having a very graceful way to handle errors and handle scale, and being able to know exactly where each piece of data is, those are the fundamentals for a modern data pipeline. So let's open the hood a little bit and look what's in there. So how does the architecture of a data pipeline look? So at first there has to be a lot of connectors, because for a data pipeline, table stakes, in order to even be able to be considered as part of the infrastructure, you need to have a lot of connectors that are able to get data from pretty much any source. So on one hand is the ability to fetch data, again, from things like RDMEBS, from transaction logs, from SaaS providers using their APIs. And on the other hand, the ability to receive data that is being pushed into the pipeline, either by just clickstream data and data that's coming from into a web endpoint, like HTTP endpoint, or data that's coming from SDKs. So for example, SDK for Android or for iOS, so every app can track data over time. Once the data goes into the pipeline, it goes through a transformation phase. And I will show in the demo some use cases for that transformation phase. But the goal of the transformation phase is to make sure that the data is ready to go. It's ready to be loaded, meaning if we need to fix it or to enrich it or to normalize it, that all happens in a transformation phase. Once it's ready to be loaded, basically need to make sure that the schemas still match the target, so no change in the schema have happened. If a change in the schema have happened, we would apply that change to the target. And then, of course, do some format conversion and load the data. Once the data is in the data warehouse, there is actually another transform step that can happen. So what we usually call that ETLT, or extract, transform, load, and transform again. As some transformations make sense on the data warehouse itself. For example, a very common example is creating roll-up tables. So let's say we have a lot of like raw tables, but we want to create some kind of fact table that is a join of a few raw tables, and then we connect that fact table to the BI tool. So that's something that makes a lot of sense to run on the data warehouse itself. So just a scheduled queries on the data warehouse. I want to pause a little bit from the technical discussion and describe some use cases from our customers in regards to how business value is created, or okay, how does it actually help to have a stable, near real-time and reliable data pipeline? So the first example is Wargaming. It's a gaming company, and with them, it was actually just a very simple cost-saving approach, because you can build a data pipeline in-house, and this is something that we actually hear from many companies. We are going to set up Kafka and Apache Spark streaming or Kafka streams, or we are going to use Google Dataflow and Google PubSub, and we're going to build our own data pipeline. And yes, you can do it. It is, I'm sure everyone has smart engineers, and they could create and build a data pipeline. However, this is something that usually costs a lot of money and a lot of time. So the time to market is very expensive. It will take usually 3 to 6 months to create a new pipeline from scratch, while with Alooma, it's a matter of minutes, as I am going to show. And it is also very expensive in terms of engineering resources. So in order to build the data pipeline properly, this is usually cost. People are a very expensive asset. So here's one example where cost saving was paramount in the business value. So it's another example is Chatbooks, and with Chatbooks, they basically wanted to get their marketing ROI, and they wanted to understand how each marketing channel that they spend money on helps them actually get customers or get revenue on the other hand. So they took attribution data and advertising data and combined it with NPS and customer support data, eventually got a very good sense of their ROI from spend. And they could determine which channels they need to invest more and which channel they need to invest less. And they could even determine which channels are driving more happy customers. And if you just look at it from the outside, it sounds nuts. I mean, how would the source channel even impact the customer satisfaction? It should be the product only, but apparently it does. Apparently, some channels are driving customers that are more inclined to be happy with the product. So this is a very good example of how getting access and getting the data from multiple different disparate silos all banded together in a simple SQL access is actually provides very good insights around what should we spend money on in order to get more revenue. Last example I want to talk about is Bringhub, where with Bringhub it's mostly around. So Bringhub are a contextual targeting platform, and they are doing mostly advertisement. And their goal is to actually, and real time is actually very important for them. They were using clickstream information, and using that clickstream information, they could target almost immediately. Use it in order to target the potential customers on different channels. So they could basically understand, okay, looking at clickstream information from the customer's website, they could understand which type of prospects are most likely to buy, or what are they most likely to do, and they could create smart targeting for those customers.